You know that enhanced button on your phone, the one that feels like a little bit of magic? Well, it's not magic. It's actually science. And today, we're going to pull back the curtain and demystify the simple but really powerful steps that can turn a good photo into a great one. So, let's dive in.
We've all done it, right? You snap a picture, and it's okay, but maybe a little dark, a little fuzzy, so you hit that one button, Enhance, and boom, everything just pops. But what is actually going on under the hood? It's a pretty fascinating process, and we're going to break it all down together.
To make this all make sense, let's treat this whole thing like a rescue mission. We're going to take one flawed image and, step by step, we'll apply the core techniques of digital enhancement to see exactly how we can bring it back to life.
All right, so our quest begins. Before we get into the how of fixing an image, we need to ask a really basic question: why are we even doing this? I mean, what's the actual goal of image enhancement?
Well, it pretty much boils down to three main things. First, we want to highlight interesting details, the stuff that might be hiding in the shadows or totally washed out. Second, we often need to get rid of that annoying digital noise. And finally, sometimes we just want to make the picture look better. It's all about making images more useful and more beautiful.
So to fix any problem, you first have to diagnose it, right? In the world of digital images, our main diagnostic tool is called the histogram. The best way to think of it is like a photo's unique DNA. It's the simple chart that tells us everything we need to know about an image's health before we touch a single slider.
So what in the world is a histogram? Honestly, it's just a bar chart. That's it. The line at the bottom goes from pure black on the left to pure white on the right, and the height of the bars, that just tells you how many pixels you have at that exact level of brightness. It's a perfect snapshot of all the light and shadow in your picture.
For example, check this out. This is the histogram for a really dark, underexposed photo. See how all the bars are just slammed over to the left in the dark zone? That's the visual proof. The histogram is literally screaming at us, hey, this picture is all shadows, there's almost nothing bright in here. Now, here's the complete opposite. This is for a super bright, overexposed image. See, all the information is shoved way over to the right side. This is a huge red flag that we've probably lost detail in the highlights, what photographers call blown out whites.
And what about a photo that just looks kind of flat and washed out? Well, its histogram was going to look like this, one narrow little mountain right in the middle. This tells us there are no real blacks and no real whites. All the pixels are just kind of huddled together in the gray midtones. So the key takeaway is simple. Just by looking at the shape of the histogram, we know exactly what the problem is.
Okay, diagnosis complete. Now for the cure.
We're going to look at two main ways to fix these kinds of light and contrast issues. Something called contrast stretching, and a more advanced trick, histogram equalization.
You know that normal contrast slider in pretty much every photo app? When you drag that thing back and forth, what you're actually doing is a function called contrast stretching. All it does is take that little narrow range of pixels we just saw, and, well, it stretches them out to cover the full spectrum, from pure black all the way to pure white. It's the most direct fix there is.
Now, for a much more powerful and automatic fix, there's a technique called histogram equalization. This is really cool. Instead of just stretching the pixels, it intelligently redistributes them. The whole goal is to spread the pixel values out more evenly across the entire range. A flatter histogram often means way better overall contrast, and that helps bring out details you didn't even know were there.
Okay, so we've tackled light and contrast. Now for the really fun stuff, details. We're talking about blurring and sharpening, and this is all done using something called spatial filtering. The easiest way to picture it is to think of a tiny, magic window that slides across your entire image, one pixel at a time.
So how does this little magic window actually work? It's a super simple process that just repeats millions of times. First, we define a small grid. It's called a mask. Then, the program places that mask over a little neighborhood of pixels. Third, it does a quick calculation on the pixels underneath the mask. And finally, it replaces the pixel right in the center with the new result. Then, it just slides over one pixel and does the whole thing again and again and again until it's covered the whole image.
Now, here's what is so incredibly cool about this. This single technique, this sliding window, can produce two totally opposite effects. It all just comes down to the math that's happening inside that little mask. With one set of numbers, you can blur an image. With a different set, you can make it sharper.
Let's put them side by side. A smoothing filter,
The one that creates blur has a really simple job. Get rid of noise and tiny, distracting details. Its mask is full of positive numbers, basically averaging the pixels to smooth them all out. But a sharpening filter, it wants to do the exact opposite. Its job is to highlight edges. And to do that, its mask has to have both positive and negative values. That's the secret sauce for finding where light and dark areas meet.
This quote right here just nails it. Sharpening is all about one thing: highlighting transitions in intensity. In other words, finding the edges. The math in the filter is specifically designed to spot places where brightness values change really fast, and then it just exaggerates those changes to make the edges look way crisper to our eyes.
So, we've looked at histograms, we've looked at contrast, and we've looked at these magic window filters. Now, let's put it all together. See, a really great enhancement isn't just one click. It's a careful combination of techniques, all layered on top of each other. And we're going to see this in action on a medical bone scan. Okay, here's our patient. It's a medical bone scan. As you can see, the original image is really flat, low contrast, and all the important details are kind of soft and mushy. Our mission is to make the fine structures inside the bone pop, and to do that, we're going to need to combine a few of the tools we've just talked about.
So here's the game plan. First, we'll apply a sharpening filter to bring out all the tiny, fine textures in the bone. Then, we use a different kind of filter that's amazing at finding the big, major edges. Step 3, we combine the results of those first two steps to create what's called a detail mask. It's basically a map of all the important stuff. Step 4, we add that map back onto the original image to make those details really stand out. And finally, we do one last tweak to the contrast to get it just right.
And here it is, the final result. On the left, where we started. On the right, our enhanced image. I mean, the difference is just night and day. Look at how crisp the edges of the bone are now, and you can actually see all the texture inside the bone. By layering these techniques, we've turned a flat, unhelpful image into one that's packed with crucial information that could seriously help a doctor make a better diagnosis.
So this fundamental process, diagnose with the histogram, then enhance with filters, this is the foundation behind almost every single enhanced image you've ever seen. It's working inside your phone's camera, it's in advanced medical scanners, and it's even being used on images from satellites orbiting the Earth.
So the next time you go to edit a photo and you slide that contrast bar or you tap that sharpen button, just take a second. Think about the histogram. Think about that little magic window sliding across your picture. What hidden story are your pixels trying to tell you? Thanks for watching.